In today's video, we're going to talk about function. The next question we're going to ask is, what is a function? A function is defined as a relation that is either 1 to 1 or many to 1. In none order have the same first element. Okay, I know the next question you're going to ask is, what is a relation? A relation is defined as what? Is a correspondence between a first set called the domain and the second set called the range, such that each members of each domain correspond to at least one members in the range. Okay, a relation is any subset of a Cartesian plane can be represented by this order. Okay, this is a relation represented like this xy relation. Okay, a relation that pairs each input with exactly one output is called a function. Therefore, a function is first of all a relation. And illustrating it, a function, we have what? Each input is related to a unique output. One input related to a unique output, and this is called a function. But in case an input has multiple output, that is not a function. But in this case, this is a function. Okay. In the other case, this output can have, and you can have an output having multiple input from it. Okay. This is also a function in this case where this one are related to this. Okay, this is a function. But if one input have multiple output, this is not a function. We move to type of function. There is a function that is injective function. A function is injective if we have f of a being equals to f of b. That implies f of a is equals to, that implies a is equals to b. If a is not equals to b, then f of a is not equals to b, and that is not injective. A function is surjective if what? If the image is equal to the codomain, that is the range, is equal to the domain. Hence, we have a surjective function. Another type is bijective. A function is bijective if it's both injective and surjective. Explain as this.
I love you.
In other case, we can test if a graph represents the graph of a function, that is a relation graph is a graph of a function, using vertical line drawn across the graph. In this case, drawing a vertical line, you find that the graph intersects at two different points. Hence, this is not a function. But in this case, this graph is a graph of a function since a vertical line intersects the graph at just a unique point. Hence, this is a function. You can draw another graph that is what? You can draw a graph like this graph. Okay, a vertical line is at only one point, and this is a function. But in case we have something like this, if we draw multiple vertical line, we are going to find ourselves having multiple points of intersection of one vertical line. Hence, this is not a function. Okay, let's figure it out again. We have a graph like this. If we draw multiple vertical line, we find ourselves having only a unique point of intersection at any point. Hence, this graph is a graph of a function. But in case we may have something like this. Let's draw something that will be a bit cumbersome. We have something like this. Something like this just to illustrate. We find that there are 2 points of intersection here and here. Hence, this is not a function. Okay, let's proceed. Which set of other pairs represent a function? Here you are asked to show which set represent a function. The first thing you're going to do is to check the x part of it. And if there's a repetition, hence it is not a function. But if there is no repetition, it's a function. Hence, here you have 1, 2, 3. This 3 and this 3 repeat, that is not a function. You have 1, 2, 3, 4, and 5. This is a function. You have 1, 2, 3, 4, 5. But there is a 1, 1, 1. We then move to the y part of it. Okay, let's figure it out again. The first thing you check the x component. If there is no repetition, hence it's a function. Okay, here there is 1, 2. This 3 and this 3 repeat, and this is not a function. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this one is a function. We have 1, 2, 3, 4, 5. That is 1, 2, 3, 4, 5 related to what? 1. One input is related to a unique output. Hence, this is a function. You have 1, 1, 1, 1. Here is not a function because it's the inverse, where we have a 1 here and we have output. One input can have multiple output. This is not a function. This and this are functions. Okay. We can have a reflection, that is a graph where there's a reflection like this one. Okay, and this one. Okay, we talk about domain and range. How to find the domain and range of a graph. Okay, range is a set of all possible input values on the x-axis, while the range is at the level of the y-axis. Okay, we are having this graph. This is the x-axis. This is the x-axis, and this represents what the domain. That is from 0 to 5 of this graph. From 1 to 5, sorry, because the graph starts at 1. That is from 1 to 5. That is the domain. Move to the range. That is the y-axis from here. That is from 0 to 4. That is the y-axis. From 0 to 4, there is a y-axis. Okay. We can also sketch a function graph by sketching it to look like this. Okay. We then move to the end of this video and solving this exercise. Which of the following graph represent the function? What is an easy way to tell that each input has only one output? Okay. I want to ask this question. How are you going to solve this? I give you a few seconds to figure it out. Okay. Your time is exhausted. We are going to use the vertical line test that is drawing the vertical line here, and it's a unique point of intersection, and this is a function drawing a vertical line here. This here they are two point of intersection. It's not a function. This is not a function. This one is a curve, not a straight line. Here is a curve, and this is a function. Therefore, this graph and this one are graphs of function. We come to the end of this amazing video. If you found it interesting, subscribe to our YouTube channel, Mr. Kim. That is Kmat Addict.